Hello everyone, my name is Benoit. I'm an application engineer for physical AI at Robotiq. And today I'm going to make a little introduction about the real-time control of our gripper. So let's get started. So first of all, before we start speaking about the real-time control of the gripper, I would like to show you the basic use case of the gripper. So here, so this is a basic pick and place performed with our gripper. So in those basic cases, the gripper control is pretty simple. So the robot goes to the part, so it goes where you need to make the picking, and we send a single command to the gripper, a close command. The gripper close on the object. So then the robot have the object, move to the box, and then release the object. So we send just a release command. So it's kind of one-time control. So we send one command to grip, one command to release. So that's the basic use case, the basic control uh, for gripper for basic application. So now let's have a look to real-time control of the gripper. And here I have a video from the JLO project. It's a teleoperation system project. So here we have an operator that control two robotic arm equipped with robotic grippers. So the robots and the grippers actually reflect in real time the motion of the operator. So here the control is really different. There is a continuous flow of command sent to the gripper to reflect really the position requested by the operator. So yeah, it's a different way to control the gripper. So there are two ways to do real-time control of the gripper. One way is to control the gripper in position. And to do that, you will use a controller like a trigger controller that have a range from 0 to 1. So the more you push on the trigger, the more the gripper will close. And if you maintain the position of the trigger, so the gripper will maintain this position. So that's position control. So yeah, that's one way to proceed. Another way to proceed is to control the gripper with the speed. And to do that, you need a controller with a range of -1, 1. So for example, here we have a gamepad controller. So with this kind of control, so if you push the joystick up, the gripper will close, and the more you push up, the faster the gripper will close. Then, if you release the joystick, so it will go to the position 0, and the gripper will just stop at the position where it is. Then, if you push the joystick down, the gripper will open, and the more you push down, the faster the gripper will open. So that's another way to control the gripper in real time. So before we speak about like the programming or the way to approach the real time control communication, so I would like to speak a little bit about the controller. So it's important when you do a real-time control application to have a good controller, a controller that is precise enough for you to send a proper input signal to the gripper. So for example, on the top here, you have a basic game controller with a trigger. Here we say that it's a quite a trigger with a short run. So with such controller, it's pretty difficult to have a good accuracy, good precision. So you can expect having some problem controlling the gripper in real time with such a controller. So if we take the example of the GLO controller, it's much more appropriate. It's a trigger that have a long run. So you can with this achieve a good positioning precision. So it's more appropriate to use such kind of controller. So I have an example here with a bad quality controller. Actually, it's a gamepad controller. I'm using the joystick of the gamepad controller. And you will see that the motion is far from being smooth, and you can barely see me moving the joystick. So the run is really too short to make a proper control of the gripper. So choosing the right controller is important when you make a real-time control application with the gripper. So you see it's pretty complicated to decently control the gripper in real time with such controller. So now just a bit some explanation about the gripper control is just a refresh. So the Robotiq gripper is controlled using the Modbus RTU protocol. So in the gripper you have some registers, and by writing and reading those registers you can control the gripper, and you can retrieve its status. So when you do real-time control, what you do is that you write in those registers at high frequency, and so you will write things like position, speed, and force. So let's have a look to the most basic approach, I would say naive approach. When people try to do real-time control with our gripper, that's the first thing that comes in their mind. So it's to control the gripper by sending position command at high frequency, and setting a speed and force parameter at a constant value. Most of the time 255 bytes to get the maximum grip force. So it's a pretty simple approach, and so we will have a look about the result of such approach. So here you can see at the bottom of the video, this is the position of the controller. It oscillates between 0 and 1, and you can see that the gripper is behaving not that nicely. It's pretty aggressive motion, because here we have the speed and the force that are at the maximum value. So really the gripper is moving aggressively from one position to another, and it does not look that smooth. So actually this approach can be improved. It's probably a bit too basic to have a nice real-time control. There are things like better than this that can be done. So instead of having a fixed value for the speed and the force, you can dynamically control send speed and force parameter to have a more appropriate motion, like a more smooth motion. So that's so looking at what is done in the field with this basic approach, and the behavior of the gripper that is probably a bit too aggressive. So so I try to develop in the pyRobotiqGripper package two functions to control the gripper in real time, with a smooth reaction of the gripper. Like so, there is a real-time position move function and a real-time speed move function. So those functions are made to be called at high frequency, and the parameter you send to those functions is the the signal of the joystick. So for the position, that would be a signal between 0 and 1, and for the speed, that would be a signal between -1 and 1. So let's have a look about the result that we get. So here, this is the position control. You see the position of the joystick at the bottom. So you see that when we request the gripper to move from two distant position, it will go quite fast from one position to another. And when we ask for small motion, the gripper will gently move to those positions. So it's kind of like dynamic control of the speed. If you want to go far, the gripper will go fast. If you want to make small motion, precise motion, the gripper will go slow. And like this, we can have a smooth motion. So now let's have a look about the speed control. So here we are. So same, you see at the bottom the signal. So if the joystick is at the center, the gripper stop moving, and the more I go out of the center position, the faster goes the gripper. So with this method, it's also possible to position the gripper with quite high precision, and you control the speed. So if you want to make a small motion, a precise motion, you can just go a little bit off of the center position of the joystick. Okay, so there will be a separate video to explain in detail how works those two functions. So thank you very much for looking at this video. So if you have any question, do not hesitate to reach us. Thank you.